Number 40, write Lewis structures for the following, and then we have A through K. Okay, so I did a very similar problem like this in number 39. That one was the more in-depth version. If you guys are starting off writing Lewis structures, go see that video. I'll go much more in depth in that video. This one will kind of be like a brief overview. So let's get started. So the first thing you need to know is in order to draw Lewis structures, which come from covalent compounds, they only deal with nonmetals. We need to know the valence electrons per each atom. So you need to know the trend. Hydrogen will always have 1 electron, and then groups 13 to 18 is 3, 4, 5, 6, and 7, and 8 valence electrons from 13 to 18. You only need this little section of the periodic table because that's where your nonmetals are. The rest of the periodic table is metals. So we only need this little section for Lewis structures. Now over here I have my foolproof Lewis structure format. Every professor or teacher is different, so your professor or teacher might want you to do it a specific way, but this will give you like a general overview, but I think that you can use this way to answer those questions on your tests or quizzes. I just find that this is the easiest way for students to learn over my years of tutoring. So let's get into it. A, we have O2. So the first thing we always want to do to write Lewis structures is write the blueprint. It looks like for this one there's only 2 oxygen atoms, so I'm just going to write 2 oxygens next to each other. Pretty simple enough. So the second part, you need to write the valence electrons around each atom. So that's when you would start drawing dots for as many valence electrons as you have. So now oxygen has 6 valence electrons, so I will just draw 6 electrons around oxygen. So 1, 2, 3, 4, 5, 6, and then I'll do the same thing for the other one. 1, 2, 3, 4, 5, 6. Now you will only make single bonds first. You'll bond only single bonds between the atoms, and then check to see for if you have the octet. So remember a single bond, so I'll put SB. A single bond is when you have 2 electrons that come together. That equates to 2 electrons. A double bond is when you have 2 electrons from each side coming together. That's a total of 4 electrons. And then you have a triple bond when you have a total of 6 electrons. So 2, 4, 6. Okay. But for right now, always just make your single bond and then check. So 1 electron from one oxygen, the other electron from the other, they will form a bond, and now those electrons are shared between those atoms. So for the oxygen on the left, you now have 2, 4, 6, 7 electrons. So we're almost there. We're not at the octet yet. This oxygen has 2, 4, 6, 7 electrons. And that's what I mean by check outer atoms for octet. Octet means 8. There are exceptions, however. Hydrogen only wants to have 2 electrons, and boron has to have 6. It wants to have 6 if it's neutral. Now, if you don't get the octet, if you don't get the 8 electrons, you will add multiple bonds if needed, and in this case, we need it. So 1 electron from the 1 oxygen will bind again to form a double bond, and then you just check. So this oxygen now has 2, 4, 6, 8 electrons. That's the octet. This oxygen has 2, 4, 6, 8. So we are good. Box that answer off. That's the answer to A. B. H2CO. Okay, well now I have multiple atoms, and I need to know which one is the center, or the central atom. The central atom is always going to be the one that is the least electronegative. All right, so that follows your electronegativity rules, and just know that hydrogen will never be in the center. So in this case, hydrogen is not going to be in the center. It's going to come down to between carbon and oxygen. Who is in the center? Is it carbon or is it oxygen? It follows the electronegativity rules. It's the least electronegative. So what are your electronegativity rules? Well, as you go across the period, remember, electronegativity, I'll just put En, increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electronegativity increases from left to right. And as you go from top to bottom, electro electronegativity decreases. So you're looking for the least electronegative, which means that in this section, these are going to be the least electronegative. These are the most, these are the least. So between carbon and oxygen, you increase as you go from left to right. So carbon would be the least, which means that carbon would be in the middle, surrounded by the 2 hydrogens, I'll put them over here, and the 1 oxygen. Now, when you're drawing Lewis structures, especially when you're starting out, you want to try to make them as symmetrical as possible. So by drawing it like this, I kind of get the symmetry of having the 2 hydrogens down below here and the oxygen up top here. So you just keep that in mind. All right, now I draw the valence electrons around each atom. So carbon has 4 valence, hydrogen has 1, and oxygen will have 6 dots around it. So I will put carbon as having 4. 1, 2, 3, 4. Each hydrogen has 1. And then this oxygen will have the 6. 1, 2, 3, 4, 5, 6. So now bond only single bonds between the atoms. So 1 electron, that makes a single bond. 1 electron, single, and then 1 and 1. So now let's just double check. This hydrogen is good because it has only 2 electrons. Remember, hydrogen bound only wants to have 2. So that hydrogen's good. This hydrogen's also good. It has 2. So they check off. This carbon has 2, 4, 6, 7 electrons. So he wants 1 more. And this oxygen has 2, 4, 6, 7. So now we make the multiple bonds. 1 and 1. That makes the double bond, and now we're good. Carbon has the 2, 4, 6, 8 electrons, and oxygen has 2, 4, 6, 8 electrons. And that is your drawing for for H2CO. C. AsF3. Okay, well, we need to figure out which one is the central. Is it going to be arsenic or is it going to be fluorine? Arsenic's over here, fluorine's up top here. As you drop down, you decrease in electronegativity. So it would make sense that arsenic would be in the middle, surrounded by 3 fluorines. So As in the middle, surrounded by 3 fluorines. We'll put F, F, and F. And now we will draw the valence electrons. So we just did the blueprint. Now we draw the valence electrons. So each arsenic has 5 valence. Each fluorine has 7. So 5 dots around arsenic, 7 around fluorine. So I'll say 1, 2, 3, 4, 5. And then for fluorine, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then we'll do 1, 2, 3, 4, 5, 6, 7. So bond only a single bond between the atoms. So 2 here will make a bond, 2 here will make a bond, and 2 here will make a bond. Now we just double check. So this fluorine has 2, 4, 6, 8. So that fluorine's good. Put the check over here. This fluorine has 2, 4, 6, 8 electrons. So that fluorine is good. And then this fluorine has 2, 4, 6, 8 electrons. That also has the octet. So if all the outer elements have the octet, chances are the inner ones will have it too. Just be careful. Arsenic has 2, 4, 6, 8 electrons. That is the answer. Box that off. Everybody has the octet. Everybody's happy. And we are moving on. D. ClNO. Okay, well now we have 3 different elements. We have chlorine, nitrogen, and oxygen. We have to figure out which one is the least electronegative, right? So if I look over here, chlorine's over here, nitrogen, and oxygen. So it seems like as you go from left to right, electronegativity increases. So which one would be least electronegative? Nitrogen. And it looks like they drew it out for you. As you go from left to right, chlorine would be on the left, nitrogen in the middle, oxygen on the right. So it looks like they were nice. But just make sure that sometimes they might not be nice. So we got Cl, N, and O. Now we will draw our valence electrons. Nitrogen has 5 valence, oxygen has 6, and chlorine has 7. So 5, 6, and 7 dots around each one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6. So make a single bond between each. So 1 and 1, 1 and 1. And now let's just double check the outer atoms for the octet. So this chlorine has 2, 4, 6, 8 electrons, so this chlorine's good. Let's check the other outer atom, which is oxygen. 2, 4, 6, 7. Not too good. So now we have to add the multiple bonds if necessary. So 1 electron from this oxygen will bind with 1 electron from the nitrogen. And now let's double check. Oxygen has 2, 4, 6, 8. Now that's good. And now let's just double check for nitrogen. 2, 4, 6, 8. We are good. So that is the answer. Box it off. Now the only thing I would suggest is just making it symmetrical as possible. So maybe I would erase these 2 electrons and just put them on the bottom. I'm just being picky, but okay. Next, E. Si, silicon tetrachloride, SiCl4. All right, well, least electronegative in the middle. Silicon's over here, chlorine's over here. As you go from left to right, electronegativity increases. So silicon would be in the middle, surrounded by 4 chlorine. So Si in the middle, Cl, 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 Cl. Now put your valence electrons. Silicon has 4, chlorine has 7, so 4 and 7 around each atom. So I got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then chlorine, 1, 2, 3, 4, 5, 6, 7. Now we make a single bond between everyone. So 1 electron, single, single, single bond, and now we just check for the outer elements. So this chlorine has 2, 4, 6, 8 electrons. So this one is good. Next, this chlorine, 2, 4, 6, 8. That's good. So check for that. This chlorine, 2, 4, 6, 8. That's good. And then the chlorine up top, 2, 4, 6, 8. All good. All outer elements are good. Let's just check for silicon. 2, 4, 6, 8. Everybody has the octet. Everybody's happy. That's the answer for this one. Box this off. And we are moving on to the next one. Okay. F. H3o Plus. Now this is the first one in this group that has a plus charge. Remember what that means. Plus means that we actually lost electrons. So plus 1 would be we lose 1 electron, plus 2 is lose 2 electrons. So first we will draw the valence electrons around each atom, and then you will account for your positives or negatives. So first you got to draw those electrons first, and then we can either gain or lose, add or take away. Now remember, hydrogen can never be in the middle, so this is down to hydrogen and oxygen. So it would make sense that we have oxygen in the middle, surrounded by 3 hydrogens. Now we put the valence electrons. Hydrogen each has 1 electron, oxygen has 6. So I'm going to put 1 around each hydrogen, and I'm going to put 6 around the oxygen. 1, 2, 3, 4, 5, 6. Now I account for that charge. This positive tells me that I lost 1 electron. Just know that when you either lose or gain electrons, you never take it away from hydrogen and you never give it to hydrogen. So don't ever touch hydrogen. So in this case, I'm just going to lose 1 electron from the oxygen, so I can pick any which one I want. In this case, I'll get rid of this one. And now you just move right on. So now you bond only single bonds, and you keep continuing the order. So in this case, I have 1 electron, 1 electron, 1 and 1, and 1 and 1. And all hydrogens will be cool because each hydrogen has 2 electrons, 2 for this one, and 2 for this one. And hydrogen wants to have 2 electrons, so they're all good. And the oxygen in the middle has 2, 4, 6, 8 electrons, so that's happy as well. The only thing with the charged compounds is you just have to box them off in brackets and state that it's a +1 charge. And that's the answer for F. So now I can add G over here. I think we got some room. G is NH4 plus. So it's a +1. Now hydrogen can never be in the middle, so that means nitrogen's in the middle, surrounded by 4 hydrogen. And now let's add our valence electrons, and then we just take them away. So nitrogen has 5, each hydrogen has 1. So I'm going to put 1 around each hydrogen, 5 around nitrogen, 1, 2, 3, 4, 5. And now the +1 means that I lost 1 electron, so you just go in and get rid of 1. Don't ever get rid of it from hydrogen, so I just take 1 away from nitrogen, I'll just take this one away. And now we just continue on. So now we just do single bonds. So there's a single bond here, single bond here, single bond here, single bond here. And all the hydrogens will be good because they all have 2. This hydrogen has 2. This hydrogen has 2, 2. And the nitrogen has 8 electrons as well. 2, 4, 6, 8. So this one is good. It just has a charge, so it just needs brackets to put +1, and G is done. Okay, so if you need to write this down, just pause the video. I'm just going to start erasing from the left-hand side, so I'll erase up until, I guess, over here. This should be good. Okay. I'll leave up G for now. But we are almost done. All right, so we got H. BF4 negative. This is a -1, which means that you will gain 1 electron. Okay, so let's see. Who's going to be in the middle? Boron or fluorine? The least electronegative. Boron's over here, fluorine's over here. Electronegativity increases from left to right. So boron would be in the middle, surrounded by 4 fluorines. So boron in the middle, F, 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 and F. And each boron has 3 valence electrons, each fluorine has 7. So I'm just going to add the dots, and then we will account for the negative charge. So each boron has 1, 2, 3. And each fluorine has 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, now let's add the electron because -1 means that we actually gained 1 electron. But now look here. I don't want to add it to fluorine because if I do, it would already have 8 electrons and it wouldn't want to bind with anything. So if I add it to any fluorine, it would want to just be by itself because it already has the octet. So that means that it would have to be bound with boron. And it looks like there's an empty space right here. So I can just add that 1 electron right here. And now I will continue with my single bond binding. So these 2 electrons make a bond, these 2 electrons make a bond, and a bond. Oop, I'm just going to erase this. This was my hypothetical situation. And now if I go around, everybody should have the octet. This fluorine has 2, 4, 6, 8 electrons. That's good. This fluorine has 2, 4, 6, 8 electrons. That's good. This fluorine has 2, 4, 6, 8. So all octets around, this fluorine has 2, 4, 6, 8. And now this boron has 2, 4, 6, 8. Now remember, boron only wants to have 6 when it's neutral. But when it's a -1 charge, it wants to have the actual octet. It wants to have 8 electrons. So this is okay. It has a charge, so we just have to box it off and put that -1, and that's the answer for H. I'll put I over here. HCCH. Well, remember, hydrogen can never be in the middle, so it looks like it's down to these 2 carbons, right? And it looks like it's being written from left to right. It looks like this hydrogen is bound to the carbon, which is bound to this carbon, which is bound to this hydrogen. So I'll just make it as symmetrical as possible. I'll say hydrogen is bound to carbon, which is bound to carbon, which is bound to a hydrogen. Now we will draw valence electrons around each atom. So hydrogen is 1 valence, carbon is 4. So 1 electron per each hydrogen, 4 electrons per carbon. So I'll just put 1, 2, 3, and 4. 1, 2, 3, and 4. And now let's add the single bond. So single bond, single bond, single bond. Hydrogens are cool because they both have 2 electrons. There's 2 here. There's 2 here for this hydrogen. So I can't touch the single bond. And this carbon has 2, 4, 5, 6. So that's not good. It wants 8. And the same thing with this carbon. 2, 4, 5, 6. So we're going to make a double bond. And I'll take 1 electron from here, 1 electron from here, and see if that did the work. This carbon now has 2, 4, 6, 7. So we're getting there. This carbon has 2, 4, 6, 7. So we could go up to a max of a triple bond. So these electrons technically are going to shift over. Isn't that neat? They shift over and they form a triple bond. And now this carbon will have 2, 4, 6, 8 electrons. That's the octet. And the same thing for this carbon, 2, 4, 6, 8. So we are good. Box that answer off. J. Whoop. ClCN. So I have 3 elements here. Chlorine, carbon, and nitrogen. Which one goes in the middle? Well, let's see. Carbon's over here. Nitrogen's over here. Chlorine's all the way over here. As you go from left to right, you increase your electronegativity. So carbon would definitely be in the middle. And it looks like they wrote it as such. Carbon's in the middle, surrounded by chlorine and nitrogen. But just know that sometimes they might not be that nice. So carbon in the middle, surrounded by chlorine and nitrogen. So now let's just put those valence electrons. Carbon has 4, nitrogen has 5, chlorine has 7. Oop, let me just get rid of that. Okay, so we have Cl, C, and N. So I'm going to put 7 around chlorine. 1, 2, 3, 4, 5, 6, 7. I'm going to put 4 around carbon. 1, 2, 3, 4. And I'm going to put 5 around nitrogen. 1, 2, 3, 4, 5. Single bonded up. So electron, electron, that's 1. Electron, electron, that's 2. And now let's just check the outer ones. So this chlorine has 2, 4, 6, 8 electrons. So that's good. That means that you can't add another bond here if you wanted to. So the chlorine is good. Now let's just check the nitrogen. 2, 4, 5, 6. Uh-oh, not good. And this carbon has 2, 4, 5, 6. So it looks like these need to make multiple bonds. So I'll make one more bond, electron to electron, and let's see. This carbon now has 2, 4, 6, 7. So we're getting there. This nitrogen has 2, 4, 6, 7. So it looks like we need a triple bond. And what I'm going to do is I'm going to take this electron and throw it up here. And this electron is going to come down here to form that nice triple bond. And now this carbon has 2, 4, 6, 8 electrons. And this nitrogen has 2, 4, 6, 8 electrons. So we are good. The only thing I would suggest is just trying to make it as symmetrical as possible. I would put the electrons on nitrogen over here to kind of have like a straight line. But it doesn't really matter. I'm just being super picky. Box that answer off. That is the answer for J. And we have the last one, K, of C2 2+. So in this case, we are actually losing 2 electrons. So let's see. It looks like I just have 2 carbons, so I'll just put C and C. Carbon has 4 valence electrons, so I will put 4. 1, 2, 3, 4. 1, 2, 3, 4. Now, I need to lose 2 electrons, so you just want to try to make it as symmetrical as possible. So I'll lose 1 from each. I wouldn't lose 2 from one of them. Just try to play fair as much as possible. It just works out better that way. So I'm going to erase 1. I'm going to erase 1 here. Now let's see. I'm going to draw a single bond. And now let's see. This carbon has 2, 3, 4 electrons. So that's not good. So let's try to make a new bond. So 1 electron from here will go in and form a double bond. And now let's check. This carbon has 2, 4, 5 electrons. This carbon has 2, 4, 5. Oh boy. So we're going to try our best here, but sometimes we might not get the octet. This electron's going to swing in over here. This electron's going to swing in. And now I could form a triple bond. And that's the best that we can do for this one, right? This carbon only has 2, 4, 6. And this carbon only has 2, 4, 6 electrons. But that's okay. Carbon actually can have only 6 electrons. It wants to have 8. It will be much more stable if it has 8, but it can exist with only 6 valence electrons. And you will see that greatly in organic chemistry. So just remember that little tidbit. It will come back. But since we have a positive charge, we have to say +2, and that's the answer. All right? So these are all the Lewis structures that we needed to do for number 40. This one is done. It was fun. It's fun to do math and draw because the math's coming up, right? I think in chapter 5 there's going to be a lot of math, so it's cool to just kind of draw. And these are fun. And if you guys are definitely going for MCAT or DAT, any of those specialized exams, we need to know organic, and this is where it starts, all right? So you guys need to know how to learn how to do Lewis structures and understand single bonds, triple bonds, double bonds, all that stuff. So you're on the right track. Thank you so much for tuning in. Hit that subscribe button, smash the like button, tell all your friends. You guys can all work together. Thank you so much, guys. I'll see you guys all in the next question. Bye-bye.